Yeah, guys, so we'll start the modern period today. Um, Again, to finishing off medicine through time in its entirety. Right, so what have we got that's new? The NHS is a big one. So by the 1900s, following on from the industrial period, we know that the government is now very much focused on helping out in public health and managing it. Also, the theories that have been discovered from the industrial period, things like germ theory, is really central to public health going forward. Scientists are starting to test more stuff out, and people are aware now of lifestyle factors and genetics during the middle of this period. Chemical treatments and antibiotics and surgery was more advanced. So, and as I said before, the government's starting to get much more involved, things like the NHS. So, huge pushes forward in terms of modern medicine and how that is helping public health. Okay, so the science and genetics. So it was clear to scientists that microbes did not cause all illnesses and diseases. Remember, the initial idea of being hundreds of microbes in the gut, and this confusing scientists about, well, why aren't they sick if there's hundreds of microbes in the gut? Well, because of the idea that not all of these microbes actually cause disease. However, there was confusion because newborn babies were born with conditions that are developed in the womb. And scientists were thinking, well, how have they been infected by microbes if they passed through the air? So that was something they needed to think about. How are diseases passed in? How are they inherited? So by 1951, scientists are theorizing that human cells can pass information from one person to the next, and this can cause diseases. But it wasn't until 53 that the technology was used to actually discover DNA. So DNA was discovered with two teams. I mean, you'll be most familiar with James Watson and Francis Crick, but also Rosalind Franklin and Maurice Wilkins. They were involved in it, and they make that connection of passed down diseases such as Down syndrome. They worked to map out the genome. It was quite complicated, but they were able to basically create a system where they could see how a woman would suffer from breast cancer and how that might be passed on in DNA. So very important in terms of the progression of medicine, DNA and hereditary diseases. Remember to have a couple of these down in your back pocket if a potential question comes up about DNA or hereditary diseases. Right, how does it work? Well, double helix together by bases, which are rungs of the ladder. DNA, list of instructions. They're grouped together by genes. Each one has a different function. So when they're mapping out the genome, when they're understanding hereditary disease, it's normally something is missing from the structure. An example, so Christopher Reeve, Superman, he'd fallen off his horse, paralyzed. Now, he wanted stem cell research. Stem cell research, very controversial because you take the stem cells from fertilized egg, so an embryo. However, this would kill the embryo in the process, so it's very controversial stem cell research. But it's how the use of DNA and things, and discovery of DNA in the human genome has been bandied around in terms of progressing, developing medicine even further. Okay, this bit is good for your evidence to basically show how DNA was eventually discovered. So in the 1900s, Mendel, he created the idea that your genes are what make up your body and they come up in pairs. However, he couldn't prove it. Then Archibald Garrod, he developed the idea that hereditary diseases were passed down, caused by these missing genes. So you can see the slow build up here. And we jump a little bit to 1941, where the American George Beadle, he proves Archibald's theory that you can inherit diseases from your genes. And in 51, so now scientists are really aware of these characteristics being passed down, you know, hair color, eye color, etc. They started to realize that human cells also pass on disease that were not caused by bacteria. However, it wasn't proved till 53 when Watson and Crick, they find DNA. They find the double helix, and they really demonstrate how this works. Right, just a little bit of an overview of why this was important. This really led to more scientific discoveries. In 2003, the Genome Project successfully mapped the location of every gene in the 23 chromosomes of every cell in the body. This allowed understanding and treatment of things like leukemia, Down syndrome, and prevention of cancer. When you're looking at a question that looks at importance for progress, really DNA is significant because it leads to all these other things. Okay, so keep that in mind when we're forming our answers. Okay, diagnosis. How are things changing? Well, it's technology, really. Technology, in particular, robotics and computers, leads to an easier way to basically scan the body. So it's a huge leap forward. They're being developed all the time, these methods, and I'll leave these on here for you. Just have a little look at. You need to know a few of these for sure. Blood tests, blood sugar monitoring, X-rays, MRI scans, CT scans, ultrascans, endoscopes, ECGs. Just again, keep a couple of these in your back pocket to bring out in potentially an explain question. Again, when you're looking at things like X-rays, it's really important for moving away from invasive surgery. Allows a clear, targeted surgical incision. But this helps the doctor really understand what's up with the patient before they go into surgery or before they're prescribed something. Okay, other lifestyle factors. So I'm just going to finish up by talking about how these factors developed during this period. First, we've got smoking. Now, smoking was really becoming more and more popular from the 1920s. It's the idea of you're young and free, you'll have a smoke. But by the 50s, the doctors are kind of seeing that rise with people who are smoking and those who are getting lung cancer, and they start becoming directly linked. You can see early on, especially post World War One, how there was a very aggressive advertising campaign which promoted smoking, and really once the doctors kind of see that lung cancer is linked to smoking, this is where you get the warning advertisements on. Basically, they prove that a variety of diseases, not just lung cancer, high blood pressure, heart disease, gum disease, tooth decay, smoking it's so preventable and dangerous to people to even inhale secondhand smoke. Smoking was huge in terms of prevention. The government could really get involved with that. Diet. So we know back from the medieval period, theory of four humours, that there was a focus on moderation and overeating, the regimen sanitatis. Although nobody believed that theory, we still, to this day, recognise that diet can have a big impact on our health. But it was very different to the ways that were suggested in the Middle Ages. So when you make these comparisons, don't think it was just like for like. Yes, there's similarities with the regimen sanitatis, but the science in the modern period was more targeted in terms of what you really should stay away from. So most people, will be aware of things like eat plenty of fresh fruits and vegetables and keep things in moderation. But there were two real important substances to be aware of: the sugar and fats. Too much sugar can cause the body to develop type 2 diabetes, for example. So again, the government really getting involved and pressuring this. Other factors. So we've got alcohol, STIs, and tanning. So alcohol directly linked to liver disease and kidney problems. So the government would highlight potential risks with the use of alcohol consumption. People are recognizing problems of STIs, sexually transmitted infection. unprotected sex normally, leading to certain diseases, and tanning, either in the sun or on the beds, led to a rise in skin cancer. So these really cover the government getting involved in lifestyle factors and making the individuals aware of what to stay away from. And we'll leave it there, guys. Hope that was somewhat helpful.